So good morning once again. So before starting this lecture, let me again remind you that attendance is very poor right now again, and only 22 students have joined. So I'm again repeating, the students are not turning up fine. The attendance is not up to mark. So the students who are not coming, they will be falling short of attendance. Again, I'm repeating, and this lecture is being recorded. Every lecture is being recorded. So that's why you can't blame me after that. Okay, sir, we have not been informed regarding this. So the last lecture, I think so, we started about air pollution, the menace of air pollution, and we discussed various aspects of air pollution, if you remember. So I told you the, like primary pollutants, secondary pollutants, how the secondary pollutants are being formed, how the technological intervention can really save these kind of, uh, menace which is going on our earth. I specifically took an example of NCR region and Punjab region, where the air is too polluted. So I'll come to that only. But if you are from Punjab and if you're from the other particular cities, you can well aware that how much air is polluted. And recently, I want to show the data to you also for India, also global data also. But if I take a case of Punjab, all these things I'm talking about, all those things I'm talking about, if I'm talking about Punjab, nine cities in Punjab are in the category of non-attainment cities. Non-attainment cities means as per the air pollution norms. In what contest they are going to have air pollution norms, they are going to measure, I told you, AQI, air quality index. The how air quality index is being measured, I told you specifically, again I'm repeating, it's a combination of all these parameters which are being written over here. 6 EPA, environmental protection criteria pollutants, so SOx, NOx, monoxide, lead, PM, VOC, particulate matter, volatile organic carbons. So 9 cities, maybe is Patiala also, Mohali also, many other cities in Punjab, they are in the category of non-attainment. Non-attainment means they are not attaining a required standards of air pollution. This means the pollution level is very high. This is recently been published or taken out. So that's why when you are talking about the solutions, preventions, first you must be knowing for what you are talking about. So for what we are talking about, that is we are going to discuss today in the class, and then we will take some other parameters also. So when we're talking about pollutants, I told you there are two category pollutants, primary as well as secondary. So primary pollutants is like you have a various categories of primary pollutants. One is SPM. SPM is a suspended particulate matter, which I told you in the class, if you remember, PM10, PM2.5, PM1. Okay. So PM is, what is this? Particulate matter is a complex mixture of airborne particles. The different size, I told you, different size, they may different origin, they may be emitted from the industry, they may be emitted from vehicular emissions, they can be from the road dust. So it can be anything. So they can be the chemical composition, yes or not. So why I'm saying chemical composition? Because once you have industry, you also have a vehicular emission, once you have road dust, and the composition may vary. So it's one of the 6 EPA criteria pollutant. So I told you specifically in the last lecture, it consists of solids in the air in the form of smoke, in the form of dust, in the form of vapor that can remain suspended for a longer period of time, and that is basically a reason when you have a haze. Haze is which is like when you have a reduced visibility. Okay. So this is extremely dangerous when you're talking about SPM or talking about PM2.5 specifically. They can really, lodge to your lungs and they can cause many problems. Then this one, primary pollutant, carbon monoxide. Okay, the monoxide, why is taken as a primary pollutant? Because why it's too dangerous. Why? because it is produced by the incomplete combustion of carbon based fuels. And when it's being released, it's going to consume oxygen from the atmosphere. And no doubt when it's going to inhale this kind of thing, I told you specifically in the last class, it lowers the amount of oxygen that enters our blood. That's why I told you last time, if you remember, कि जब stubble burning होती है तो stubble burning के time आप देखो आपकी air में carbon monoxide कितनी है, how much monoxide is in the atmosphere. It is huge, it is at severe level. Whatsoever the recommended um, constraints are there, recommended constraints are there, okay, this much should be there in the air, and it is more than, extremely more than that, that is in severe category. Okay, so once you're going to inhale these kind of things, you will feel suffocated. Why is feel suffocated? Because it is going to consume oxygen, so it lowers the amount of oxygen that enters your blood. Okay, so ये चीजें हैं जो हम आपको डिस्कस किए थे जिसके बारे में. So you need to work on the technologies, fine, कि कैसे करना है कैसे नहीं करना है. और मैकेनिकल इंजीनियर तो इसमें बहुत ज़्यादा इन्वॉल्व है बेटा. Why I'm saying this? Because most of these activities like emission activities are related to the vehicular pollution. Vehicular pollution means you know very well the engine emissions. What kind of engine emissions I'm going to discuss in the coming slides, no doubt. And then this is again a CFC and carbon dioxide. Okay, CFCs, you know, chlorofluorocarbons, they are being released from the air conditioning and refrigeration systems. So nowadays, like when it was realized that the CFC which are being released, they are going to react with the ozone layer in the stratosphere. So it leads to the destruction of or reduction of the ozone layer. So that's why slowly and slowly all the CFCs is banned, and only on that CFCs were chosen. If you see the literature, those who are not going to cause any harm to the ozone layer in the stratosphere. Okay, then carbon dioxide. So carbon dioxide principally initially was not considered as a primary pollutant or criteria pollutant. Why? Because CO2 is a complete combustion activity, CO2 is being released. But what happened in the past, like few years back, it was taken into the criteria pollutant, or it's a pollutant. Why? Because of that greenhouse effect. ग्रीन हाउस इफेक्ट क्या होता है? जब कार्बन डाइऑक्साइड रिलीज ही बहुत ज्यादा होगी एटमॉस्फेयर की कंसंट्रेशन के साथ अकॉर्डिंगली बहुत ज्यादा रिलीज हो गई, तो आपको पता है ग्रीन हाउस इफेक्ट क्या होता है? तो ग्रीन हाउस इफेक्ट वही है बेटा कि आपकी अभी जो समर्स हैं, समर्स में कभी हमारा 40 से ऊपर टेम्परेचर कभी नहीं गया. We have witnessed these things fine, like since we were young. But nowadays when we have 48, 46, 47 temperature, this is just because of the global warming. Global warming means you have increased blanket of carbon dioxide gases at a certain atmosphere ऊपर. ओके, तो वहां पे ऊपर ब्लैंकेट बनी हुई है CO2 की. कहां से बन गई बेटा ये? क्योंकि हमने जो रिलीज की है कहां जाएगी बच्चे? इट्स गोइंग टू मेक अ ब्लैंकेट टॉप. और रीजन बता दूं फिर आगे मूव कर जाऊंगा. इसमें होता क्या है? IR radiations, infrared radiations, when they come from the sun, they are short wavelength. Short wavelength means they are having high energy. E is equal to hc by lambda, Planck's law. E is equal to h nu is equal to c by lambda. So lambda is a wavelength. The wavelength is short, energy is high, so they can easily penetrate through the carbon dioxide layer which is being formed at the top, find the atmosphere, just because of the man-made activities. Now once the IR radiations comes through that blanket of carbon dioxide, or the gases over there, now they're going to strike the earth, the different materials, all the activity on the earth, they're going to consume that IR radiations and release again these radiations. When they're going to release these radiations, they are high wavelength. High wavelength means less energy, so they will be not able to penetrate back that particular layer, CO2 layer blanket, which is being formed due to man-made activities. So they will keep on reflecting back to the earth, so that the earth temperature increases. बेटा ये बहुत बड़ा एक कंसर्न बन चुका है ग्लोबल वार्मिंग का, CO2 का. आपको पता है कि अब पूरे वर्ल्ड में एक ही चीज पे काम हो रहा है, हाउ टू रिड्यूस द CO2 emissions. और इसमें सबसे बड़ा जो रोल निकल के आ रहा है वो मैकेनिकल इंजीनियर्स का निकल के आ रहा है. कैसे आ रहा है कि अब आपको बताऊंगा बेटा. एग्जांपल छोटी सी देता हूं, फिर आगे मूव कर जाऊंगा. और एक छोटी सी चीज भी छोटी चीज भी पूरे वर्ल्ड में CO2 रिलीज के साथ कोरिलेट किया जा रहा है। कैसे, मैं एग्जांपल देता हूँ फिर आगे मूव कर जाऊंगा। बेटा आपके घर में बेटा जितनी भी ट्यूब्स लगी हुई हैं CFL है, सपोज CFL है, सपोज मैं एग्जांपल दे रहा हूँ, तो CFL is 36 watt. When it's 36 watt, so if it is running for 8 hours, now you calculate accordingly how much kilowatt hour you're going to consume in a single day according to the CFL tubes, and according to this kilowatt hours how many units are you going to consume. Now if you really convert or replace all these CFLs to LED, LED which you will be requiring at home will be near about 12 watt to getting the same luminance. So 12 watt and 36 watt, 12 watt and 36 watt, you can mark a difference. No doubt less energy is consumed, less kilowatt hours consumed, accordingly less electricity units are consumed. Less electricity units means you have avoided the CO2 release in the atmosphere. In what sense? यार ये प्रोड्यूस कहाँ से हो रही है अपनी इलेक्ट्रिसिटी? कोल पावर प्लांट से। पावर प्लांट में क्या यूज हो रहा है? कोल यूज हो रहा है। सो उतना कोल कम बर्न होगा, उतनी टेक्नोलॉजी कम यूज होगी, जितनी यूनिट्स आप अपने कम कर रहे हो, एंड उतना CO2 रिलीज सेव हो जाना है। एंड दैट्स व्हाई दिस इज कॉल्ड CP, क्लीनर प्रोडक्शंस। और जितने भी मैकेनिकल इंजीनियर्स हैं, दे आर नाउ बीइंग like told to work towards CP. They are working towards production, but we don't need production right now. We want CP, cleaner production. Cleaner production का मीनिंग ये है बच्चे, इसका ये नहीं कि कपड़ा और प्रोडक्ट बिल्कुल साफ आना चाहिए मेरा, वो नहीं है। Cleaner production means you are going to use the technology in that particular way so that the minimum raw materials are consumed, less waste is being generated, and minimum gases are being released, and the minimum energy is being consumed. Minimum energy means you're going to save a lot of energy. That means you're going to save carbon dioxide emissions. So ultimately, the whole world is coming to that particular point. Okay, then SOx and NOx. NOx means nitrogen oxide, SOx means sulfur dioxide. So these are basically, SOx and NOx basically are coming from like petrol, diesel, or fuels. Most of the fuel which we are getting is containing a sulfur. So you need some kind of removal mechanism or some adsorption mechanism in your chamber, in your vehicle also, or in industry also, where these gases can be avoided, because once they are being released in the atmosphere, they are going to produce smog or acid rain, which is very much dangerous. We can't avoid consuming fuel. We can't avoid consuming these diesel, petrol, all kind of stuff. They have to be used. Okay, so you need to take care about the technology in that case. Now, this is something, sources of air pollution. You need to know about this once you have talked about primary and secondary pollutants, all kind of stuff. Now, the sources of pollution are two always, natural and man-made. If you see, natural and man-made, that is anthropogenic. So natural means by default they are going on. What you can do, that's volcanic eruptions, polar grains, that dust particles come to atmosphere by default, forest fires and dust storms. You can't do anything when you are talking about natural, but can you have a technological interventions? When you have technological interventions, can you really avoid, I'm not saying avoid, but reduce the impact of natural sources? For example, मैं आपको बता रहा हूँ, फिर आगे मूव कर जाऊंगा बेटा. Like forest fires is the biggest contributor towards this air pollution. Volcanic eruptions, these are seasonal. Not seasonal, I'm saying, but occasional. Fine. Dust storms again very seasonal, bete. Polar grains again very seasonal. They are not going to give much contribution, but forest fire is a major contributor, because every city, they have a very good percentage of the area which is going to have a forest. And no doubt, when you have a good amount of area dominated to forest, so then what are the chances that the forest fires can go? Like last year, if you take California, Australia, Melbourne, all kind of stuff, they had a bad time totally bad time when they have like forest fires. There's a drastic forest fire over there, and कुछ technology वहाँ पे काम नहीं आई. They have sprayed everything. So last year, when the offline classes were there before pandemic, some students, they worked under me in first year to um, work get an idea on the forest fires and how to get rid of forest fire. Actually, we can control beforehand. We can, because forest fire का क्या होता है बच्चे कि like it started from a particular area, from particular spark, suppose, and when it spreads throughout the jungle or forest, okay, then it's a point of concern because not easy to now control. It's तो बच्चों ने बेटा प्रोजेक्ट बताया, and they've shown me that project. It's a beautiful. But after that pandemic happened, we were not able to execute that further, but we'll try to take it further. Fine. So that is basically they make a drone with sensors. So drone with sensors going to cover the area with the deep forest inside, and going to sense any fire activity in terms of that smoke coming out from the thick forest, and that signal from the sensor is taken through the cloud computing to your network sitting somewhere else. So we get an idea that this area of the forest is having some problems in terms of smoke coming out. So you have a better idea right now. Okay, this might be due to some kind of fire that has been started over there. Sorry. So before actually it reaches to a large level, you better take care of this. And then उसके बाद mitigation का भी बच्चों काम किया इसके बारे में. So I'm not going to discuss all kind of things. That's what I'm saying कि you have our areas wide open in front of you. We have plenty of problems in front of us. Thing is, we need to have that vision to look where we want to pitch in. So man-made, I think so. Man-made, you have a very, very, very large scope to work upon because this is a man-made. This will be continuing activity because we have here point source, area source, mobile source. Point source is basically talking about when exactly one point you can pinpoint, like industries, power plants, they are situated at particular point. So you can really pinpoint from chimney, the dust, the air is coming out, the polluted air is coming out. You can reasonably take a sample over there and get the idea whether the air which they are releasing is polluted or not. Then area source is basically talking about when you have stubble burnings, okay, open burning everywhere. So this is like you get the idea so that you can really work upon these kind of menaces. Then mobile source is something like that vehicular pollution, railroads, all kind of stuff. When you're talking about they're traveling from one place another place, each and every time their position is changing, and that is much more dangerous. It's easy to control point source, but it's not easy to control non-point source. Non-point source, I'm talking about mobile sources. Okay. So these are sources of air pollution you can really go through because these things are very important. When you are working on some project as a mechanical engineer, fine, you need to know about this kind of data. When you are working on transportation activities, you need to know when you are modifying an engine, what type of pollutants you are dealing with. That is, when you have transportation, you have lead, you have carbon particulates, you have SOx, yeah, these kind of things are there. Okay, being a mechanical engineer, I told you specifically, you can't say like that, sir, I have developed my engine, my work is over. No. You must have read the case of Volkswagen, because they have manipulated the data with related to emission standards, and the company suffered a billion dollar loss because the company was banned. And I'm specifically telling you which are now worldwide. If you're doing a core things, they are very less appreciated. And if you're doing things related to climate, your technology, mechanical related to climate, related to emissions, related to these kind of things, you're taken into hands. So these are the sources of air pollution. You can go, so biomass burning, basically I'm talking about biomass burning, beta. I told you specifically in the last class also. Because in India, 70% population near about lives in villages. And out of this 70%, 90% population, they go for open burning, for chullas, for their, like food. And this is something very major contributor towards these kind of thing. And here, this is a major contributor, CO. Why CO? Because when you see these chullas, you might have seen the chullas in villages where the cooking is being done. And when you put the utensils on the top, there is a least space available where the oxygen can no come in. So when the oxygen sources are limited, then there's an incomplete combustion. When there's an incomplete combustion, it is but obvious that CO is released, carbon monoxide is released. So this is something, like you want, you should, like many persons are working on this area. Like they are saying that villages are there, for technology can take a boom over there. So they are working on stove design for villages, effective stove design. स्टॉप का डिजाइन करेंगे, कर रहे हैं बच्चे, और उसमें एंटरप्रेन्योरशिप पे निकल रहे हैं बच्चे कि गेटिंग इट अप्रूव फ्रॉम द गवर्नमेंट, कि ताकि दिस हैव अ बेटर combustion from taking air from every port they want to design in a stove, and there will be maximum burning of biomass that's you're going to use and ultimately converted to CO2, not CO. So this is something I really wanted to share with you. So you have a multiple areas we're going to work on. So this is something I was discussing with you. Okay, the emission sources in gasoline fueled cars. You have a different places where your hydrocarbons, HC is a hydrocarbon. Okay, they are getting released to the atmosphere. So first of all, they are getting mainly from the fuel tank. Okay, then emissions. You have again unburned hydrocarbons are being released. Then there may be a carburetor displays, and you have evaporative hydrocarbons. Because the hydrocarbons are evaporative, you must, क्या है बेटा, वही चीज है, just when you go to the gas stations or petrol stations, or get the diesel or get the petrol in your car, moment they take out that pipe, immediately you smell that diesel. Okay, this is hydrocarbons. The hydrocarbons. Okay, so you have a different sources where this can release. So when you're talking about your combustion process in the engine, okay, you know better being a mechanical engineer better. A perfect engine, that's again oxygen in the air, because you're getting air in, not oxygen in, fine? Because air contains 21% oxygen. You could convert all the hydrogen in the fuel to water and oil ideally, and all the carbon in the fuel to carbon dioxide. And this is called complete combustion. Once you have complete combustion, then you say maximum power is being generated. Maximum power means least emissions, better efficiency. Okay, so this is some I'm talking about. So these, you have a spark ignition, you have a compression ignition. You might have read somewhere. So these are the emissions. From spark ignitions, you have this thing. When a compression ignition, you can have NOx additionally. Sorry, PM, particulate matter additionally. So these are the emission standards. Just to go through, you know very well. I'm not going to give you detail for these kind of things. Euro standards and Indian standards. And although the Euro standards when talking about are much more tougher when talking about BS standards. So you go through please. So these are the scales of air pollution. Like where you're going to talk about scale of air pollution, you are talking about local scale, you're talking about urban scale, you're talking about regional scale. Local scale means, like you're talking about city, your city basically, where you're taking about, you are, located up to 5 kilometers of surface. Okay, so impacts from single source or group of sources. Like you are in Ludhiana, so industries, how they are contributing towards Ludhiana. Okay, then urban scale means we're talking about whole urban area, that's order up to 50 kilometer, talking about a state. Okay, 50 kilometer. So you are talking about larger areas. So you now have to take certain other points into considerations. Because local scale, you're taking about some local issues, but on to urban scale, you have to take all the activities related to urban area. Like you have the transport activity and the outer periphery of that kind of urban areas, indoor activities, outdoor activities, how many villages are there around that particular urban areas. All kind of things will come into picture, that when you want to design that, you take into all these points into consideration. Then regional scale, about a particular region, okay, 500 to 7,000 kilometers. Then you have a country to continental scale, fine. So many thousands of kilometers you're talking about. North region, south region, this one, okay. Then whole country. Then you have a global scale. The global scale is talking about, जब हम एक बात करते हैं ना global क्या scene है, तो we are talking about what is the effect of, like this globally, how the pollutants are being transported globally. और सबसे बड़ी एग्जांपल नीचे लिखी हुई है आपकी राइट में, एंटार्क्टिक ओजोन होल। ओजोन कहाँ पे है? एंटार्क्टिक रीजन में है। तो उस एंटार्क्टिक रीजन में पढ़ना कभी भी सीएफसी कैसे पहुंच गए बच्चे? अंटार्कटिक के बाद तो कोई इंडस्ट्री नहीं है। अंटार्कटिक तो आपको पता ही एरिया कैसा है बेटा, उसके तो 1000 किलोमीटर के इधर भी कोई इंडस्ट्री नहीं होगी बच्चे। और पॉपुलेशन भी नहीं है वहां पे, सीएफसी रिलीज हो गए, तो सीएफसी वहां कैसे पहुंच गए? ठीक है, वही चीज मैं बता रहा हूँ आपको बेटा, हाउ द पोल्यूटेंट ट्रांसपोर्ट अक्रॉस द ग्लोब। ठीक है, और कैसे क्लाउड फॉर्मेशन होते हैं, कैसे क्लाउड की मूवमेंट होती है, जस्ट गो थ्रू इट। आई एम नॉट गोइंग टू गिव यू डिटेल्स फॉर दैट, यू कैन रियली गो थ्रू। सो दीज आर इफेक्ट्स ऑफ एयर पोल्यूशन। मेरे ख्याल से कहने की जरूरत नहीं है, आप बेटर जानते हो बेटा। ठीक है जी। So effects of air pollution are basically on humans, on animals, on materials and plants, everywhere. ठीक है जी। And this is something I want to show to you beta. This is recently being released 2020 globally. Globally. So what the data says, out of top 10 cities which are polluted in the world, 9 are from India. Recently 2020, last year it's been released यार। 21 का तो हो नहीं सकता, तो 20 तक डाटा लेंगे वो सारा। So see, 9 out of 10 are from India. How? उसके बाद भी हम कहते हैं कि हम टेक्नोलॉजी वाला शहर है। अब देखो मैं अगर एग्जांपल ले लूँ यार, इसमें भी दिल्ली आईआईटी यहाँ पे है, कानपुर आईआईटी यहाँ पे है, ग्रेटर नोएडा सारे यहाँ पे है, नोएडा यहीं पे सारा कुछ। तो देखिए, दिस अ ह्यूज गैप बिटवीन टेक्नोलॉजिकल इंटरवेंशन and between implementation, and this something like that. This is something very alarming here when you're talking about this 9 cities are from India. I'm talking about global right now, throughout the world. And see only one particular city from China, hot on China, and देखना अगली बार भी निकल जाएगी, वो इतने शार्प हैं सिग्नल टेक्नोलॉजी इम्प्लीमेंटेशन में। ओके और ये मैं कुछ आपको बताता हूँ, फिर आगे मूव कर जाऊंगा बेटा। और मैकेनिकल इंजीनियर्स के लिए बहुत इंपॉर्टेंट है चीज। ठीक है, ये कुछ मेरे ये था कि मैं कैसे इसमें वर्कआउट कर सकता हूँ। particular effect of vehicle pollution created by start vehicles on the signals। वही बात होती है बेटा, सिग्नल्स आपका 50 सेकंड्स का है। ठीक है जी, वहीं खड़े हैं आप, इंजन ऑन है, and maximum emissions are being there when you have a vehicles standing on, especially जो एनसीआर बंदे वो बेटर बता सकते हैं आपको। कुछ ऐसे तो है वहां पे, बताते हैं बच्चे, कुछ ऐसे सिग्नल्स हैं दिल्ली में जहां पे 5 बार भी टर्न नहीं आती, और वो 5 बार भी टर्न नहीं आती तो वो सिग्नल्स ऑन, व्हीकल्स ऑन रहते हैं आपकी। और थर्ड पॉइंट देखोगे, ये मैंने यूरोप में देखा था बेटे, मैं आपको तो बताने वाला हूँ। सिंक्रोनाइजेशन ऑफ ट्रैफिक लाइट्स। व्हाट इज दैट? सिंक्रोनाइजेशन इज व्हाट? वो मैंने यूरोप में देखा कि जैसे एक सिग्नल ऑफ हुआ, क्योंकि यूरोप में क्या है, बड़े छोटे छोटे स्ट्रीट्स हैं, क्योंकि यूरोपियन कल्चर बहुत ओल्ड है, बहुत वर्ल्ड का सबसे ओल्ड कल्चर यूरोपियन का है। तो बहुत छोटे 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 पॉइंट्स हैं, जैसे हमारे वो ना पुराने मोहल्ले होते हैं सिटीज में, ओल्ड मोहल्लाज होते हैं। एक स्ट्रीट आ गई, फिर अगली स्ट्रीट आ गई, अगली स्ट्रीट आ गई, अगली स्ट्रीट आ गई, विदिन 50 मीटर्स के डिस्टेंस में स्ट्रीट्स हैं। वहां वैसे ही यूरोप के अंदर है। और मैंने वहां पे देखा कि जैसे वो एक सिग्नल ग्रीन होता है तो बाय डिफॉल्ट उस लाइन में जितने भी सिग्नल हैं वो ग्रीन हो जाते हैं। सो बड़ा अच्छा देखा। क्यों? क्योंकि इट रियली अवॉइड्स कंज्यूमिंग एक्सेस फ्यूल, बिकॉज यहाँ ग्रीन है, अगला रेड, अगला रेड है, अगला ग्रीन। और यहाँ पे जब आके देखा मैंने, ठीक है, आप थापर भी आगे चुके हो मेरे ख्याल से, आप बेटर अंडरस्टैंड कर सकते हो बेटा कि थापर से जब बाहर निकलते हैं टुवर्ड्स 22 नंबर फाटक, तो जैसे यू टर्न लेते हैं पहला सिग्नल आ गया, यू टर्न लेके 50 मीटर जाओगे नहीं, वो नाबर रोड वाला अगला सिग्नल आ गया, और वो टुवर्ड्स 22 नंबर वो कैफे कॉफी डे के सामने वाला थर्ड सिग्नल आ गया। तो हमारे इतने कम डिस्टेंस के अंदर 3 सिग्नल है, लेकिन आपको तीनों कभी लाइन में ग्रीन नहीं मिलेंगे। तो वही आ गया बेटे कि टेक्नोलॉजी की इंटरवेंशन है ही नहीं इस चीज के लिए। नोबडी हैव वर्कड आउट, इट कैन बी वर्कड आउट इजिली यार, वो कर सकते हैं, हम नहीं कर सकते बेटा, सीधी सी बात है, हम करना नहीं चाहते। और एक और प्रोजेक्ट बताया था मैंने बच्चों को, आप भी कर सकते हो विद मैकेनिकल एंड इलेक्ट्रॉनिक्स कंबाइनली कैन यूज दिस प्रोजेक्ट, ठीक है, वो बहुत अच्छा प्रोजेक्ट है बेटा। बात वही होती है कि कौन पहले जंप इन करेगा, इंटरेस्ट ही नहीं है जब बच्चों का बेटा। दैट इज, वो भी मैंने ऑब्जर्व किया कि इतने ट्रैफिक सिग्नल्स हैं, जैसे पटियाला में 22 नंबर वाला मैं अभी तक याद है, जो सीसीडी वाला है, कैफे कॉफी डे वाला है, वो भी तो कैफे रहा नहीं वहां पे, जो वो सिग्नल है वहां पे, ओके, कि वहां पे क्या है कि जो मेन रोड है दैट इज हैवी इन टर्म्स ऑफ व्हीकल्स, जो बाइसेक्शन वाली रोड है साइड से आती है, उसमें ट्रैफिक कितना आ जाएगा यार। तो दोनों के आप नंबर सेम क्यों रख रहे हो, व्हाई यू कीपिंग द नंबर्स और वेटिंग नंबर्स फॉर टू सेम। तो क्या होता है कि वहां पे ना वो लग जाता है, ट्रैफिक डेंसिटी बेस्ड सिग्नल लग जाते हैं। ट्रैफिक डेंसिटी बेस्ड सिग्नल्स क्या होता है कि वहां पे आपका एक सेंसर लग जाता है जो आपकी डेंसिटी सेंस करता है कि जिस एरिया में कार की मूवमेंट बहुत ज्यादा हो रही है, कार व्हीकल्स बहुत ज्यादा आ रहे हैं, तो वो क्या करता है, उसके अकॉर्डिंगली उसके सिग्नल की काउंट कम कर देता है। और जिस एरिया में वो विद टाइम सेंस करते नहीं है कि यहाँ से व्हीकल जब एक बार ग्रीन हुआ, 5 ही 10 व्हीकल निकले और एक साइड में 50 व्हीकल्स निकले, तो मेन रोड होगी ना, तो मेन रोड वाला सिग्नल आप 20 सेकंड का कर देगा अपने आप, वो डेंसिटी देख के, और इस साइड वाले का 60 मिनट कर देगा, 60 सेकंड कर देगा, सॉरी। सो दिस इज समथिंग प्रैक्टिकल यार, एयर पोल्यूशन सेव कर रहे हैं, पोल्यूशन सेव कर रहे हैं, वो फ्यूल सेव कर रहे हैं, ना कोई व्हीकल मॉडिफाई किया, कोई इंजन मॉडिफाई नहीं किया हमने। हाँ, अपनी टेक्नोलॉजी को ऐसी जगह पे लगाया कि बाय डिफॉल्ट आपका व्हीकल पोल्यूशन सेव हुआ, CO2 लीज सेव हुई, एमिशन सेव हो गए, फ्यूल सेव हो गया। सब मैटर ऑफ थिंकिंग, मैटर ऑफ इम्प्लीमेंटेशन। आधे बात तो पता नहीं चलता क्या करना क्या है। देखिए जो मैंने ये वाला बताया आपको, एंड दिस प्रोजेक्ट कैन बी इजिली डन, easily done. There's no any mass theory involved in these kind of projects. Thing is now you have to get into that kind of mode, and so that accordingly you can work on this kind of thing. And you have excellent professors, teachers working in Thapar University, and capstone project, wonderful idea. You can take this project in capstone project. So these are few examples I am taking. Villages blame refinery for the crop damage. मैंने बताया ना अभी आपको effects of air pollution. तो this is an example. ये आपके ट्रिब्यून की रिपोर्ट्स हैं जो मैं लेके आ रहा हूँ. So the next part is which we're going to touch in the air pollution. After that, we're going to cover some of the APCDs, no doubt, in the air pollution. The air pollution control devices, वो डिटेल में जाने वाले हैं बेटा उसके बारे में. पहले उसके बारे में थोड़ा सा पहले मेट्रोलॉजी एंड एयर पोल्यूशन. व्हाट इज दैट मेट्रोलॉजी? मेट्रोलॉजी क्या है बेटा, मैं बताने वाला हूँ आपको विद टाइम थोड़ा सा. मेट्रोलॉजी इज बेसिकली टॉकिंग अबाउट कि आपके पोल्यूटेंट एक जगह से सेकंड जगह पे कैसे पहुंच गए. सो हाउ दे आर मूविंग फ्रॉम वन प्लेस टू अदर प्लेस. सो उसमें कैसे मेट्रोलॉजी प्ले करती है. अब देखो बात मैंने वही बताई ना आपको, जब भोपाल गैस बता रहा था, जब यहाँ पे स्टेट की थी, अगर विंड डायरेक्शन उल्टी होती तो शायद इतने बंदे ना मरते. आगे विंड डायरेक्शन, विंड स्पीड कम होती उस दिन तो इतने दूर तक इफेक्ट ना जाता, बंदे ना मरते. तो ये विंड स्पीड, विंड डायरेक्शन, ऑल काइंड ऑफ थिंग्स। और अगर उस रात को बारिश पड़ जाती, जिस दिन भोपाल गैस ट्रेजेडी हुई, तो ये इम्पैक्ट इतना कम होना था कि कभी कोट भी नहीं होना था। अभी आपने ध्यान से देखा होगा बेटा, मैंने जो आपको एयर क्वालिटी इंडेक्स बार बार बता रहा हूँ, एयर क्वालिटी इंडेक्स, जिस दिन बारिश पड़ती है ना बेटा, उस दिन अपनी मोबाइल ऐप के एयर क्वालिटी इंडेक्स देखना, बहुत कम होता है, गुड क्वालिटी में आ जाएगा, देख लेना। रीजन बहुत ऑब्वियस है कि द प्रेसिपिटेशन ऑफ द रेन is going to wipe out the pollutants which are present in the suspended in the air और सीधा ग्राउंड पे आ गए सारे, एयर में रही नहीं। So these are things which I'm discussing: wind speed, wind direction, precipitation, rainfall, जो भी rainfall, as basically the part of the meteorology you are talking about. And this is going to decide the fate of air pollutants present in the air. तब इसको डिस्कस थोड़ा सा करने वाले हैं आगे इस लेक्चर में, और थोड़ा अगले लेक्चर में फिर वाइंड अप कर देंगे इसको बेटे। ठीक है जी। तो भाई ये चीज ये है कि अगर यहाँ पोल्यूशन है ना बेटे, वो यही रहेगा, इट गोइंग टू ट्रैवल टू सर्टेन हार्ड प्लेसेस और सम अदर प्लेसेस। So meteorology is what? Is concerned with the description of the transport of pollutant from source to receptor. Okay, this is source, this is receptor. So see this, it's a fine 5 miles from here, and wind direction is this. Okay, so wind direction is going to take these pollutants which are being released by industry 5 miles downstream to these hotels and houses. Now these houses can never, or hotels can never imagine or judge where from these kind of pollutants are really coming in. So meteorological elements, they have a most direct and significant effect, no doubt, on the distribution, no doubt on the dispersion. What is that dispersion? I'm going to discuss with you, of air pollutants in the atmosphere. So it is totally dependent कि ये ऊपर से निकल जाएंगे, ये नीचे आ जाएंगे, इनके घरों में आ जाएंगे, ये यहीं तक रह जाएंगे, या ये उल्टे यहाँ चले जाएंगे. तो it all depends upon the meteorological elements. So they have a direct effect and significant effect. So how? Which we're going to discuss in the class. So dispersion. So dispersion थोड़ा discuss कर लें, फिर हम आपके 5 मिनट आउट लेंगे अगर यहाँ किसी के. Dispersion talking about pollutants which are released in the atmosphere are subject to the phenomena of 4 things. Just remember these 4 things, but all of you. Transportation, dilution, modification, removal. Transportation, dilution, modification और removal. अब वो है क्या, समझ लो, एक पढ़ लो उसको एक बार बेटा, स्लाइड्स पे आपके सामने मैं समझा भी रहा हूँ आपको बच्चे. How they are being transported, how they are being diluted. अब डायल्यूशन क्या होती है बेटा, सिंपल सी बात, को एग्जांपल देता हूँ आपको, या मॉडिफिकेशन और रिमूवल. ठीक है, अब एग्जांपल फिर आगे मूव कर जाऊंगा बेटा. एक ग्लास लो पानी का बच्चे, छोटा सा ग्लास लो, उसमें इंक की ड्रॉप डाल दो. तो जैसे आपने इंक डाली, that water is somewhat become inkish, that blue is first blue. Now अब क्या करो, इस पानी को जिसमें एक ड्रॉप डाला इंक ग्लास वाले को, इसको एक बकेट में डाल दो. तो जैसे बकेट में डालोगे, hardly you see any kind of color because it's now faded away. It's not faded, its term is diluted. तो डाइल्यूट हो गया, तो डाइल्यूट हो गया, उसका इफेक्ट भी कम हो गया. मेरी बात समझ रहे हो ना. तो वही है, अगर हम इसको डाइल्यूट कर दें, कैसे डाइल्यूट कर दें, देखो चिमनी से पोल्यूटेंट बाहर निकले, जैसे चिमनी से पोल्यूटेंट बाहर निकले या कहीं से पोल्यूटेंट बाहर निकले, जैसे ही बाहर निकल के ओपन एटमॉस्फेयर में आएंगे, तो ओपन एटमॉस्फेयर में उसको लार्ज वॉल्यूम्स ऑफ एयर मिल गया. तो लार्ज वॉल्यूम एयर जो मिली है वो प्योर मिली है ऑलमोस्ट. जब वो प्योर मिली है ऑलमोस्ट, जो पोल्यूटेंट रिलीज हुए हैं तो उसमें जाके डाइल्यूट हो जाएंगे, उसमें जाके थोड़े से डाइल्यूट हो गए. अब अगर वहां पे विंड स्पीड अच्छी है, विंड स्पीड क्या करेगी, इसको ट्रांसफर्स और ट्रेवल करा के आगे ले जाएगी. जैसी आगे लेके जाएगी, उसको नई एयर मिल जाएगी, नई एयर मिलेगी तो वो फ्रेश एयर है, तो उसमें फिर डाइल्यूट होगी. तो मैंने जब एग्जांपल दिया आपको भी, तो दिस मींस जितनी डाइल्यूट होती जाएगी उतना आपकी पोल्यूटेंट का इफेक्ट कम होता जाएगा. तो बैकग्राउंड कंसंट्रेशन पोल्यूटेंट की कम होती जाएगी. सो रीड द सेकंड पॉइंट वेरी केयरफुली, ट्रांसपोर्ट एंड डाइल्यूशन, जो अभी मैंने क्विज एग्जांपल समझाई है बेटे आपको, causes the dispersion of pollutant into the atmosphere, which really reduces the background concentration of the pollutant. Okay, so these modifications and removal results in the atmosphere get rid of these kind of pollutants. तभी तो हम चिमनी की हाइट नहीं रखते हैं. कभी आपने देखा होगा ट्रैवल करते हुए, इंडस्ट्रीज क्रॉस करते हुए, you have a chimneys and they are made to, like have some suitable heights. These suitable heights कैसे देखी जाती हैं? सिटी के अकॉर्डिंगली. पटियाला की अलग है, बठिंडा अलग है, या कहीं और हरियाणा अलग है. क्यों? क्योंकि हर सिटीज में विंड स्पीड अलग अलग है. जहां पे विंड स्पीड बहुत ज्यादा है, जिस एरियाज में, किसी स्टेट में विंड स्पीड बहुत ज्यादा है, वहां पे कम हाइट की चिमनी भी चल जाएगी. क्यों? कम हाइट की चिमनी मीन्स उस कम हाइट में आपकी विंड स्पीड अच्छी है बच्चे. विंड स्पीड अच्छी होगी तो विंड स्पीड के अकॉर्डिंगली पोल्यूटेंट्स दे कैन बी ट्रांसफर्ड टू द लार्जर डिस्टेंसेस. वंस दे आर बीइंग ट्रांसफर्ड टू लार्जर डिस्टेंसेस मींस आई टोल्ड यू एट एवरी पर्टिकुलर माइल दे आर गोइंग टू हैव अ न्यू एयर. So once a new air is there, now background concentration always decreases. I told you with the example. I think so you know better. So अब ये बहुत डिपेंड करेगा किस पे, जो ये वाला पॉइंट है. This dispersion which I've told you depends on the climatic conditions. Temperature क्या है, pressure क्या है, prevailing winds क्या है, humidity क्या है. Okay. So it's important to discuss the turbulence level of the atmosphere. Okay. So this is something I'm talking about, but I'm going to discuss this thing right now. जो बता चुका हूँ इसके बारे में, बाकी next class में करेंगे बेटा. This is I'm talking about source, receptor, and how they are being transported, and sometimes it's possible that they can be re-entrained into the atmosphere where it's very dangerous. Re-entrainment happens when you have a don't have any kind of thing which you can have a dilution is occurring. तो लोअर हाइट पे है, वो बताएंगे विद टाइम आपको. आई वांट टू डिस्कस दिस काइंड ऑफ थिंग्स. सो बेसिकली डोंट गो फॉर दिस फिक्स्ड लॉ ऑफ डिफ्यूजन. फिक्स्ड लॉ ऑफ डिफ्यूजन क्या होता है? मास ट्रांसफर बेटा. मास ट्रांसफर इज व्हाट, कि हाउ द पोल्यूटेंट्स आर बीइंग लाइक released from the low concentration to high concentration, high to low, sorry. ठीक है. तो पोल्यूटेंट रिलीज हाई कंसंट्रेशन, यहाँ पे लो, तो ये डिफ्यूज होंगे. तो डिफ्यूजन की जो लॉ है वो ये वाला है. J इज मास फ्लक्स, D इज डिफ्यूजिबिलिटी, dc by dx is the concentration gradient. Just go through it beta, don't to cram these kind of things. Okay, just this is a mass transfer phenomena basically. Okay, so this I told you, I think so this is something. The diffusion of pollutants occur due to turbulence, which further depends upon this parameter. कितना क्या condition है, wind velocity क्या है, wind direction क्या है, humidity क्या है, atmosphere stable है, unstable है, all these things are there. Roughness factor I'm going to discuss in the next class, no doubt. So I think so I should stop here before actually, giving you details of these kind of things. So that we'll discuss in the next class. So I should stop here.